Maybe you want to remove everybody named Scott. How might you do that using a list? So you either have to modify it or copy it. So you'd either modify in place and actually remove things, which is good if you really want that to be the long-term goal, right? But if I just wanted to do it for this one operation, I'd have to create another list over here and then copy the items that I care about and omit the ones that I don't care about, right? So now I've got an entire new copy of things here. With streams, you don't do that. If you filter, you're passing things through this chain of operations, and you say, oh, I don't care about it, don't pass it to the next guy. So it's basically a chain of responsibility, if you've heard of that in the Gang of Four design patterns. And you're going to pass to something, you may pass it to the next guy in the chain or not. You may modify it and pass it to the next guy in the chain. Make sense so far? In a stream, you have a couple types of operations. You have a terminal operation, and this is where you return the final result. So you're done doing any stream processing. So you've got an element and you return some result out of it. And then we have intermediate operations, which just continue passing data down through the stream after some potential modification of that data. Okay, so there's no intermediate data structure created for these things. When you filter things out, you're not creating another list. You're just not passing things to these operations. That's the way you want to think about these guys. Okay, now you can think about all these operations as being lazy. You don't compute data up front. You compute data when it's pulled. So if you think of this chain of operations here,